Okay, factor the expression. So, how many terms we got here? We got 1, 2, 3. So 3 terms. I need to figure out what the GCF is. And then I need to make my t-table, 1x to the fourth minus 12x to the second minus 64. Okay, and then I look through this, the greatest common factor. Remember, there's 3 things you check for, and then you got to do DOPS after that. Okay, you got to do a difference of perfect squares check. Okay, so first I look on the last term. There's no variable. Okay, I look at the first term. There's no negative there. Okay, so I'm checking here for the variable, here for the negative. And then 112 and 64 is 1. Okay, so I'm not going to go through with that. Okay, so I go ABC. 1 times negative 64 is negative 64. So a negative, that would be a positive multiplied by a negative, and I'm trying to add the factors to get to negative 12. So 1 and 64 does not accomplish that. 2 and 32 does not accomplish that. 3 is a decimal, so 64 divided by 4 is 16, and right there is my negative 12. Okay, now we got to pay attention to what the A term is, because that drives how we do the parentheses. So if A is a 1, you're allowed to now drop the 1 and then split that, so it's x to the second, x is second. Okay, so we just need, since I was able to drop my coefficient, I just need 2 parentheses with x squared plus 4 and x squared minus 16. Okay, now bring that up here, and you do another dot step. Now, if it's got a plus, it automatically can't be a difference of perfect squares. Now, if it has a minus, you got to check, well, it has a difference sign, or those perfect squares. Well, x to the second is x times x, and 16 is 4 times 4. So we go to 2 parentheses, 1 plus, 1 minus, and then be x, and then 4, 4. Okay, oh, sorry, I jumped the gun here. Plus, minus. Should be done up here. So we had a plus, so that drops, and you have a minus here, but that x right there isn't a perfect square. You can't write just x as something times itself, so that's NA. Okay, and so that's why that has been dropped. So that's my answer there. Okay, x to the 4th power minus 64. So we have a binomial. There's 2 terms now, 2. So with 2, I figure out what the GCF is of the expression. And then after that's done, I see if I have a difference of perfect squares on the spot from here. So 2 parentheses, 1 with plus, 1 with minus. Okay, so DOPS question mark. Okay, GCF, check the last term for, if you need x, your last term will have it, but you don't, so you can't do x. You also don't want to do a negative because that's positive. Then the coefficients 1 and 64 would just be 1. So we're not going to do that on that one either. Okay, so I'm going into the original expression since I didn't write anything new. And I have a minus, okay, so it's a difference of perfect squares. Well, let's drop that 1. We don't need it. X to the 4th is x to the second times x to the second. And then 64 is a perfect square because that's 8 times 8. So it'd be x to the second 8, x to the second 8. Okay. Now, see if we can do a difference of perfect squares. Well, the plus can't be. Okay, now the minus, well, x to the second is x times x, but 8, it's not 4 times 4, that's 16. Okay. 8 is not a perfect square, that's NA, so then that's done as well. So x to the second plus 8, x to the second minus 8. Okay, let's go to properties of exponents. So we have 3 to the second times 3 to the third, so I underline the expression, I make 3 lines. So on top, my factors are both 3s, so I write 3 down once and I just add the exponents. It'd be 2 plus 3, which makes 5. Now that 5 is a positive, so the 3 to the 5th stays in its position on top. And then 3 to the 5th simplifies, it's 243. It's It's not 3 times 5. You take 3 times 3 times 3 times 3 times 3. Okay, next problem. So on top, I have a factor of 3, and on bottom, I have a factor of 3. So I have 6 and 4. Now remember, we look for common factors. When we have something on bottom, we see if we have that common factor on top, which we do. So we cross out the factor that has the lower exponent, then subtract 4 from 6, which is 2. So it's positive 2, so it stays in its position. Then 3 to the second is 9. So that simplifies into a value of 9. Okay, next problem, I have a parentheses, and inside 3 is to the third power, then outside's to the second power. So my only factor I have to worry about is 3, but it's in a parentheses, so 3 is distributed to 2, and that's 6. Okay, it would stay in its position, and then 3 to the 6th power is 729. Okay. Okay, next problem, 3 to the negative third. So the only factor you got is a 3, it's to the negative third, but it needs to switch positions because it has a negative exponent, so it goes to bottom, then the negative 3 switches to a 3. Okay, and then I evaluate 3 to the third to 27, but then we need to cover the top up with a 1, so it's 127. Okay, now you're going to get some variables, so you have a parentheses with 3d to the second, and then to the third, then 2d to the second. Okay, remember these are times operators, 3 times d times 2 times d. You need to put your operations in. Okay, so the first factor I have is a 3 times d times 2, and there's another d. Well, I already wrote d the first time, so I'm just adding to the power. So 3 is to the 1, but it's in parentheses, so 1 times 3 is 3. Now there's 2 factors of d. First one's to the second, 2 times 3 is 6. The other one's to the second, so 6 plus 2 is 8. Okay, then 2 is to the first power, and it's not in a parentheses, so it would just remain to the first power. We would not take 1 times 2 because there's no parentheses. Now all 3 of these exponents are positive, so all 3 factors stay in position. 3 to the third times d to the 8th times 2 to the first. Now I can evaluate the 3 to the third and the 2 to the first. So 3 to the third, 3 times 3 times 3 is 27. And then 2 to the first is 2. You put those together, then the variable hangs out behind. And then I would take 27 and times it by 2, which is 54. So 54 times d to the 8. Okay, next one, we have a parentheses with 3x. It has a negative fourth outside of it. Alright, so everything's on top. My 2 factors are 3 and x, so I write 3 times x. Now what are the powers? 1, 1, so we distribute 1 to negative 4 and 1 to negative 4, so that would both be negative 4. Okay, well both of these need to switch their positions so that their exponent can become positive. Then 3 to the 4th simplifies to 81, and then the x factor just remains itself, and we cover the top up, the numerator, with a 1. So 1 over 81 times x to the 4th. Okay, next problem. On top we have a division line. On top you have x to the negative second, and under that you have x to the third times x to the second. Okay. So on top I have an x factor. On bottom I have an x factor and another x factor, so I'm just going to add those. So the top x is to the negative second power, then down underneath you got 3 and 2. Well, 3 plus 2 makes 5. Now you want to see if you can cancel when you have things on bottom. You have x on top and bottom. You cancel the letter with the smaller exponent, negative 2 smaller. But you don't just minus 2. See, that was a negative 2, so it's minus negative 2. Which goes to plus 2. 5 plus 2 is 7. Okay, so x to the 7th stays in its position. It really can't be simplified. It does need a 1 over it though. Okay, 1 over x to the 7th. Okay, then the next example, we have 2e in parentheses, a negative 4th power outside, and then g to the 5th. And then on bottom we have e to the 5th and g to the negative 3rd. So So in the numerator you have 2 times e times g. In the denominator you have e times g. Okay. So 1 times negative 4 is negative 4. 1 times negative 4 on the e, put a first power there, and it's negative 4. Then the g is to the 5th, and then the e on bottom's to the 5th, and the g is to the negative 3rd. Now you see if you can cancel things out. Well, you got e and e, so the lower e is canceled, and you don't minus 4, you minus negative 4, because that's what you had. So that'd be plus plus, 5 plus 4 is 9, okay? And 5 and negative 3, you cancel the lower power, but you don't minus 3, you minus negative 3, which is 5 plus plus 3, which is 8. Okay. All right, so out of these factors, the 2 has a negative exponent, so it moves down and it becomes a positive. The g has no reason to switch positions, and neither does the e because it has a positive power, e to the 9th. Now, out of those factors, the only one that can be simplified is a 2 to the 4th, which would be 2 times 2 times 2 times 2. That's 16. So you have g to the 8th on top, and on bottom we have 16 times e to the 9th. Can't multiply anything, okay? Now we're going to discuss end behaviors of the function. Okay, I have this function y equals negative 8x to the 7th plus 16x to the 6th plus 9. As x approaches positive infinity, what does the function do? Because y is a function of x. As x approaches negative infinity, what does y do? Well, we need to write this so it's in proper form. Or actually it already is, okay, because you have x to the 7th, x to the 6th, and constant, so we're good to go. So the leading coefficient is negative 8. So since it's negative, that means the end behavior on the positive side, it goes down. It's negative. Now your degree determines the other end behavior, but it's not a negative positive. The degree is 7, which is odd. So the end behaviors have to be opposite, okay? So we know what our first end behavior is. To make it opposite, it would be positive infinity. Okay, next one, y equals 1 minus 4x minus 6x to the 3rd power minus 15x to the 2nd. Well, this needs to be in the proper formation. See, the highest exponent I have is the 6th power. That's the only one I have, so negative 15x to the 6th. Then the next highest is the x to the 3rd. Next highest would be the x, and then the constant always goes in the end. Okay, so the leading coefficient is a negative 15, which means the end behavior here is negative on the positive side. And then the degree is going to be 6. Well, that's an even exponent, so then it's even. So now instead of opposite end behaviors, the end behaviors have to be a match. Okay, so my end behavior has to match what's going on there, which would be negative infinity. Okay, y equals x to the 3rd power minus 14x minus 4. You already have the highest power first and the x and the constant, so we're good. We don't have to rewrite it. It's in the proper order. So the leading coefficient here would be 1. Okay, so it's positive, so that means we'd have positive infinity. Okay, then the degree is 3, which is an odd degree. So the end behaviors have to be the opposite, okay? So the opposite of a positive infinity would be negative infinity. Okay, next one's in good order, x to the 4th, x to the 2nd, then my constant. Okay, leading coefficient here is 1, okay? Well, that's positive 1, so that's going to be positive infinity on that side. And then the degree is 4, which is even, okay? So it's even, they have to have the same end behavior, okay? So positive and positive.